Welcome Pure Maths 3 students to week 20 of maintenance. The first question today is a modulus question. We've got modulus on both sides, so best way to solve this is just to square both sides. So we get 2 squared into x minus 1 squared equals 3 squared into x squared. Now I end up with 4 x squared minus, what's that, 2, so 8x plus 1 plus 4 should be equal to 9x. So I've skipped a few steps there, but should be okay. Then I'll bring everything across to the right hand side. So I get 5x squared plus 8x minus 4 equals 0. I'm going to factorize that, so I think it's 5x minus 2x plus 2, 10 minus 2, yep, equals 0. So we get x is equal to 2. Minus 2, or in the first case, 2/5. Okay, so those are our values. Now, it says for the next one, which is log question, hence solve this. Now, what you hopefully notice is that you've got this and this being replaced with this and this. So we can go straight to business. So we can say 5 to the x equals negative 2. And of course, no solutions. And you can think about why that might be. If you were trying to plot 5 to the x, it's going to be something like this, isn't it? Okay, there's no negative 2 value in that. There's an asymptote at the x-axis. Okay, the other option is 5 to the x is equal to 2/5. And all we're going to do there is we're going to go log base of 5 of 2/5 is equal to x. And I get negative 0.569 as my answer to 3 significant figures. So that was quite an easy one, really, wasn't it? Okay, by expressing the equation cosec minus blah, 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 in terms of cosine. Okay, solve the equation. So we're trying to get rid of everything, so we've just got cosine. Okay, so I'm going to rewrite this as cosec theta, which is 1 over sine theta, equals 3 sine theta plus, now cotangent theta is like 1 over tan, so we could write this as cosine theta over sine theta. Now at this point, what could we do? I could say, my next line I could bring, I could say 3 sine theta is equal to 1 minus cosine theta all over sine theta. So I've just simply taken this across to the left hand side, and they've got the same denominator, so just simplified the fraction there. I'm going to times both sides by sine, so I get 3 sine squared theta equals 1 minus cosine theta. Then I can use my old pure maths 1, sine squared theta equals 1 minus cosine squared theta identity. And we're getting there. 3 minus 3 cosine squared theta equals 1 minus cosine theta. So we bring everything across to one side. So we're getting 3 cosine squared theta minus cosine theta minus 2 equals to 0. And I'm thinking of factorizing at this point. And I think that's it. Alright, so now we've got some results that we can use. So cosine theta equals negative 2/3 or 1. And we're looking at the range between 0 and 180. So we have theta equals inverse cosine of negative 2/3, or and I should say. Now this is 180 here, and that we're looking between 0 and 180. But 0 is less than, so because we've got this less than sign, we've actually got nothing here, so we can ignore that one. We're going to have a negative 2/3 here. Now when I plug that into the calculator, I'm getting theta is equal to 131.8 degrees. So differentiation looks like we're using the old product rule here. So we'll say u equals sine x, therefore du dx is equal to cos x, and we've got v is equal to cos 2x, therefore dv dx equals to 2 negative 2 sine 2x. Alright, now we're ready to put this into our formula. So remember, the dy dx using our product rule is equal to u times dv dx plus v times du dx. So in this case, we're going to have sine x, and we're going to times that by negative 2 sine 2x. So I'll just write it like this. And then I've got v. So for v, I've got cos 2x, and then cos x, cos 2x. Okay. Now what can we do at this point? We're trying to find the stationary point. So at the stationary point, we could say at SP, we know that negative 2 sine x sine 2x equals, plus cosine x cosine 2x equals 0. And what could we do here? I guess we probably want to get rid of these. We want to use our double angle rules. Well, my highlighter's not working as usual. Work already. No, it's not going to work. Okay, I got sine 2x and I got a cosine 2x. So maybe we'll go minus 2 sine x, and we're going to pop that into 2 sine x cos x. And then for the cos 2x, I'm going to try and get everything into cosines. So I'm going to go 2 cosine squared x minus 1. This should be equal to 0. Now, remember, this is on your formula sheet, and you want to get used to being able to use these, the double angle rules. Now, let's see. So I'm going to get minus 4 sine squared x cosine x plus cos x into 2 cos squared x minus 1. Now at this point I'm going to divide both sides by cosine x, so I can get rid of this and this. Right? So this will give me minus 4 sine squared x plus 2 cosine squared x minus 1 equals 0. And I can rewrite, maybe I'm going to times everything by positive, by negative 1. So I'm going to go 4, no, I'm going to go minus 4 into 1 minus cosine squared x plus 2 cosine squared x minus 1 equals 0. And I'm going to go minus 4 plus 4 cosine squared x plus 2 cosine squared x minus 1 equals 0. And we'll clear a little bit of space for ourselves. Oh, we can't do that. Things not working as usual. 6 cosine squared x minus 5 equals 0. Okay, so we get cosine squared x equals 5, 6. Just bringing those things across the other side. So cosine x equals plus or minus square root 5 over 6. And now we're looking between 0 and pi over 2. So I'm going to get my results. So x equals, now if I do with the We want to be in radians, remember, so make sure you set your calculator to radians. Inverse cosine of square root 5 over 6, and I'm getting 0.421. Now, if we do the negative square root 5 over 6, we get 2.72. And this is out of our range, because pi over 2 is less than that. So those are the only two that we're going to have, only ones, we're going to have one in our range for that one. Okie dokie. Nextly, we've got this curve. We've got to show what dy dx is. Now, I'm going to differentiate with respect to x. So I'm going to go x cubed ddx plus minus, wake up, minus, and I've got to use my product rule here. So I'm going to go 3x squared y times ddx, so I've got to differentiate that one, plus, I guess we can go, now we're going to go 3x squared, we're going to differentiate that with respect to x, and then we've got y, and then plus y cubed ddx equals, and we drop that 0 out. 3 drops out when we differentiate with respect to x. Now, next line we get 3x squared minus, and we've got the 3x squared here, and when we're differentiating y with respect to x, we can replace it with y dy dx, because it's the same. You can see the d, like if you just think about it, like the dy's cancel out, right, and you're left with ddx. So it's the same thing, but we can first differentiate the y with respect to y, and that will leave us with the dy dx. Now the next one is 6x y, close bracket, and then we're going to do the same with this y cubed, so it'll be d dy and then dy dx. Okay, now next line, we're going to get 3x squared minus, and we're going to drop that y will drop out, won't it, dy, so we'll just be left with 3x squared dy dx, and I'm just going to apply them, I'm opening up my brackets now. The next one is going to be minus 6xy plus, now the next one will be 3y squared dy dx equals 0. Now at this point in time, maybe I'll just move everything over to here. I'm going to get my x, my dy dx's over to one side. So I'm going to go 3x squared minus 6xy equals, then we have 3x squared dx, dy dx, minus 3y squared dy dx, and I can factorize that out. Dy dx, and then in the brackets I've got 3x squared minus 3y squared, close brackets, and so last I get dy dx equals, and I've got on the top I've got 3, and maybe I can factorize this at this point, x squared minus 2xy over, and I can factorize this bottom bit as well, 3x squared minus y squared, cancel, cancel, and we've shown what we needed to show. Okie dokie, so the next one we are trying to do integration, and we've got to find the exact value of this here. Now you can see that we're going to use integration by parts. So what I'll say is u equals x, therefore du dx equals to 1, and I'll say that dv dx is going to be our e to the negative 2x, and therefore v is equal to minus 1/2 e to the minus 2x. Now we're ready to go. So this equals minus x over 2, so I'm minus x over 2, combine it with e to the negative 2x, so u times v. Just doing u times v there. Remember, this is equal to uv minus the integral of v du dx. Okay. Alright, so that's that bit, and then we're going to go minus. Now we need integral of v. Now v is negative 1/2 e to the minus 2x, and u drops out completely because we've got this 1 here. Oh, and I should have here my 1/2 limit and 0. This is 0, 1/2. I'm going to do all the limits at the end. Dx equals, and then at this point I will have minus, now I could take what could I do at this point? I guess minus, and then I integrate in there, so I'd have minus 1/4. Minus 1/4, that's a very messy quarter. Let's fix that. Minus 1/4. No, it's going to be positive, isn't it? Positive 1/4 e to the minus 2x. And then I'll put the limits on the outside. I haven't quite got there. So I guess next line, x over 2 e to the negative 2x minus 1/4 e to the negative 2x plus, oh, we don't need plus c, and then we just put our limits in, 1/2. Okay, and when we do that, oh, we could actually even factorize further, so we could go e to the negative 2x bracket, and then we could go negative x over 2 minus 1/4. I could even take the half out there as well, couldn't I? But anyway, I'll just leave it there. Okay, now you just want to make sure you don't make any mistakes when you're doing this. When I'm doing it, I'm getting minus 1/2 e to the negative 1, so putting in our half value there. And we'll get, yep, so I'll take away 1/4, and then the next one, minus 1/4 is the next one, so my final answer should be 1/4 minus 1/2 e to the negative 1. Well, that's what I got for that one. And now onto the last question. We're trying to write in partial fractions the following. So we can write this type, can't we, as a over x plus 1 plus b over x minus 3 plus c over x minus 3 all squared. Now, this means that we're going to get a into x minus 3 all squared plus b into x plus 1 x minus 3 plus c into x plus 1 equals 4x squared plus 12. I'm going to say, first of all, let x equal 3, and then we can find out, we can drop out a and b. And so we get 4c equals now 3 times 3 is 9, 4 nines are 36, 46, 48. So it's 48, and so c is equal to 12. Then we're going to go let x equal -1, and so this will drop out our c and b, leaving us with 16a equals 16, so a equals to 1, and then 1, and then equate x squared coefficient. And so if you look at the ways that you can make an x squared, obviously this one, and the only other one is the b one. Okay, so we know that a is 1, so that will give us x squared, plus bx squared equals 4x squared, so b is equal to 3. So if we were to write this out, we've got 1 over x plus 1 plus 3 over x minus 3 plus 12 over x minus 3 all squared. Now, we're trying to obtain a expansion of this, so I'm going to in turn expand each bit. So the first one I'm going to expand is x plus 1, so I'm going to expand this one first. Now, what I'm thinking for this is I'll just rewrite it, because we've been used to seeing them like this, to the -1. And so that's nice and easy. So we get 1 minus x plus, and then we have -1 times -2 over 2 factorial times x squared. So that's easy. That gives us 1 minus x, and then plus x squared. So we've done the first one. Now let's consider the next one. This one, I'm going to rewrite that as 3 bracket minus 3 plus x to the -1. And then my next line is 3 times -3 to the -1, and this will give me 1 minus x over 3 inside the bracket there to the power of -1. And obviously these cancel out, don't they? That and that. We just end up with -1 minus x over 3, and that will be to the power of -1. Okay, so the next little bit will be negative, and then I will expand. So I get 1 plus x over 3, because it would be -1 times minus x over 3, plus, and then we've got -1 times -2 all over 2 factorial into negative x over 3 all squared. Now when we work that out, I'm getting -1 minus x over 3. And this last one, what would we get there? So it'll be positive x over 9. And so when we times it by the negative on the outside, so we get -x squared over 9. Okay, so we've got the second one. Our final one is this one here. Now what are we going to do with this? So my first step is to write it as 12 bracket, I guess -3 plus x to the -2. And then I will rewrite it as 12 times -3 to the -2 into, and then I'm going to go 1 minus x over 3 all to the power of -2. And so I will get, what's that, 12 over 9, which is 4 over 3. So -4 over 3, -4 over 3, bracket, and then I can go 1 plus 2x over 3. And then the next one, plus, no, hang on, plus -2 bracket negative 3 all over 2 factorial into negative x over 3 all squared, and that's as far as we need to go. So this will be minus 4 thirds bracket 1 plus 2x over 3. Now what is that? What will we get there? 3 over 9. So 1/3 x squared. X squared over 3. I think that's right. Oh, but wait a second. I've forgotten something. Just reviewing what I did here. When this should actually be a positive, shouldn't it? Okay, because it's a negative 3 to the power of negative 2. That's like negative 1/3 times negative 1/3. Okay, that was a bit foolish. Never mind, picked it up. 4 over 3 plus 8/9 x plus 4x squared over 3. And now all we need to do is add all of these terms together. So it's a bit of a dog, this question, isn't it really? 1 minus 1, so okay, so we get 4 thirds for our non-x term. Now looking at our x terms, if we turn them all into ninths, we've got negative 3/9, negative 9/9, so negative 12/9. So I think it's negative 4 over 9, negative 4 over 9 x squared. And then we look at our x squared terms, so we've got, let's do them into ninths as well. So 9 take away 1, which is 8, plus 4, so I think it should be 12 over 9, plus 12 over 9 x squared. Oh, sorry, that one is x. Okay, now I guess we can simplify that. So that's 4 thirds minus 4/9 x, and then plus 4 thirds x squared. And that will be our final answer for this one. Well, I hope that makes sense, team. Hope you're feeling more confident as we keep on practicing and head towards our exams. God bless.